Problem states that a contractor is to build a warehouse whose rectangular floor will have an area of 4,000 square feet. The warehouse will be separated into two rectangular rooms by an interior wall. The cost for the exterior walls is $175 per linear foot, and the interior wall will cost $125 per linear foot. Part A says to write a function to model the contractor's cost for building the walls as a function of the length of the interior wall. Let's start out by creating a diagram. First, we need to draw the rectangular warehouse. Then we need to draw the interior wall, separating it into two rooms. We need to model this as a function of the interior wall, so the length of the interior wall will be the independent variable x. The outer walls on the left and right share the same length as the interior wall, so they will equal x as well. The longer walls will be y. From this diagram, we can assume that one formula we would use to find our function is the area formula for a rectangle. Area equals length times width. In this case, the length is x and the width is y. The area is given in the problem, which is 4,000 square feet. Therefore, our equation for area will be 4,000 equals x times y. We will put that in the top left for later. We need to write a formula representing the cost per linear feet, so we need to find the perimeter of the walls. The perimeter formula for a rectangle is perimeter equals 2 times length plus 2 times width. We've established that length equals x and width equals y, so our perimeter formula becomes p equals 2x plus 2y. However, we have to include the interior wall, which means we have to triple the length rather than double it. So now our formula is perimeter equals 3x plus 2y. Before we model the function, remember that the independent variable is the length of the interior wall, x, and the dependent variable is the cost, c. Since the cost is based on the length of the walls and not the area, we'll be using the perimeter formula as our main equation. The interior wall cost $125 per linear foot, and all four exterior walls cost $175 per linear foot. One x represents the length of the interior wall, while the other two x's and two y's both represent the length of the exterior walls. So the function becomes c equals 125x plus 175 times 2x plus 175 times 2y, because we have one x that is $125 per linear foot, two x's that are $175 per linear foot, and two y's that are $175 per linear foot. The p in the perimeter formula was replaced with a c to represent the dependent variable cost. Since we need to write a formula for cost as a function of the length of the interior wall x, we need to find a way to replace the y in the cost equation with x. The area formula contains both x and y, so we can use it to replace y with x in our function by isolating the y in the area formula. So our area formula is 4,000 equals x times y, which means if we divide 4,000 by x, it equals y. So now we're going to use that and our cost equation to get our function. First, we need to simplify our cost function. So all we need to do here is distribute the 175s into the 2x and the 2y, and we get cost equals 125x plus 350x plus 350y. And then we can combine or add the 125x plus the 350x, and we get cost equals 475x plus 350y. Since we're creating a function for c of x, we need to replace y. We've established that y equals 4,000 over x, so we can replace the y in the equation with 4,000 over x. Finally, we distribute the 350 into the fraction to simplify our function. So the function modeling the cost for building the walls as a function of the length of the interior wall is c of x equals 475x plus 1,400,000 over x.